always have other videos.
Okay, yesterday we transformed. Okay, yesterday we transformed square root functions. Now we're going to solve square root functions. So right here at the top of the page, they actually did the first one for you. I kind of hate it when they do this, but we're gonna step through it just so we can see everything they did. So how can we solve this equation algebraically? The first and most important thing you need to know is that you must isolate the radical. That means whatever is over there with the radical, it all needs to be in the house. So you're going to get rid of any outside the house pieces. Now, in this case, everything was already inside the house. So they kind of skipped that step because there wasn't anything to do. You didn't have to isolate it because it was already isolated. The second step is to square both sides, because in order to get D by itself, I need to get rid of that 18. But I can't get rid of the 18 until I get rid of the house that is grouping them together. So we square both sides, and that squaring a radical just cancels it. So on the right-hand side, the house just gets canceled. On the left-hand side, you have to square that number 2, because remember, anything you do to one side of an equation, you also have to do to the other. So you square the 48, and that's where the 2304 comes from. So I got 2304 equals 18, and then you just simplify and solve. So I have to get rid of 18, divide both sides by 18, and I get D equals 128. Now, this is hugely important. With these problems, you have to check. Now I know since 8th grade, 7th grade, 8th grade, the first time you started doing algebra and solving for x, your teacher taught you could take x and plug it back in and check and make sure you were right, yes? And you did it at first because they said you could do that, and then they might have graded you on it a few times and made you do it, and then after that you quit doing it, right? You have to do it on these, because these create what are called extraneous roots. That create extraneous roots, and this is one of them. Extraneous meaning extra. So you'll solve the problem. It's not that you did anything wrong. Used to, when you learned this in 8th grade or in 9th grade and you checked your answer, it was to check to see if you did something wrong. It was to check to see that you solved it correctly. Now that's not what this check is about. This is about finding a root that was an answer when you solved the problem, but when you plug it back in, it doesn't work. And these types of problems, now sometimes you'll have them and sometimes you won't, but you won't know if you don't check. So you have to check these. It isn't optional. Alright, so let's do a couple. So, first thing you got to do is isolate the radical. So we're doing example number 2. I have to isolate the radical, get the house, everything outside of the house has to be on the other side. So I got to get rid of that 5. How should I do that? Minus 5. So now I have square root of x minus 3 equals 4. I am now isolated. Everything that's over there now is all inside the house. So the next step is to square both sides. Anything you do to one side of an equation, you have to do to the other. Squaring the left-hand side, squaring a radical just cancels it. That's it. So I get x minus 3 equals 16. And now you're going to add 3 to both sides. And I get x equals 19.
So to check it, you have to
Now to check it, you've got to go back and plug it back into the original problem. So I'm going to plug 19 right there. And I am going to write this one out, but you can probably check most of them in your head. But let's write this one out just for the sake of saying we did. So 5 plus square root of 19 minus 3. So 5 plus square root of 16.
Yep.
Did I do something wrong?
No.
Okay. 5 plus 4 equals 9. 9 equals 9. Okay, so now I can say that it is in fact an answer because I checked and it is not an extraneous root. Everybody okay?
Yes,
Good.
ma'am.
Alright.
Wait, did you not get X equals
I have a
9?
question.
I got x equals 19. Yes.
What if you solve it all the way and you did like everything right, but you don't get the right root?
You mean like I have to plug it back in and it doesn't work? Then there would have been no solution.
Oh, I see.
Okay.
You were supposed to get your worth 9,
different.
right? Whenever you check it, equals 9.
Yeah, 9 equals 9. Is everybody okay?
Yeah.
Alright. Okay.
Wait, can we just shut our?
Yeah.
Can we just plug it into our calculator? And
Yeah,
if
you
it
can, but
equals-
what if you don't have your calculator? Then you have to do it by hand, right? And you're good with that. Okay, yes, then you can plug it in. Okay, so now, next one. Isolate the radical. So this time I have to add 3. Okay, now, I need to square both sides in order to get rid of the radical. So on these, you gotta be careful. I'm gonna square both sides. Ah. When I moved that 3 over to the other side, that moving it over there grouped it with what was already over there. So what that means is this now becomes a binomial that I'm going to have to FOIL. Now on the left-hand side, squaring it just cancels the radical, so I just have x plus 5 on the left. On the right, I'm going to go ahead and write this down as x plus 3 times x plus 3. So that would give me x squared plus 6x plus 9. Okay, so far so good? Okay, now I have x squareds and x's in the same problem. That makes this problem quadratic, which means everything has to be moved to one side, and you can either factor or use the quadratic formula. So I'm going to move my x and my plus 5 to the left. So subtract x and subtract 5. So I get x squared plus 5x plus 4. I prefer to factor. So that factors, anybody got it?
1 and 4.
That's 1 and 4.
Positive both.
X plus 1, x plus 4. Which means my two answers come out to be x equals negative 1 and x equals negative 4.
Why did you just subtract that x with the first x? Why did you go straight to the negative, or this?
Because this first x is squared.
So you can't subtract it?
Right.
Okay.
So how do you plug this back in? You just plug them both into each X?
Okay, I'm glad you asked that. You have to do them each separately. So I'm going to take negative 1 and I'm going to plug negative 1 here and here and solve it out. And then I'm going to do it again with negative 4.
Oh.
So I'm going to write it down. You will get to the point where you can definitely do this in your head, but so I got negative 1 plus 5 minus 3 is negative 1. Okay, so negative 1 works because I plugged it in.
So you have to draw an equal sign, right?
One?
You
I
have
mean,
to, you have to put an equal sign on it?
no. Not if you're plugging in negative
Or do
1.
you just put negative 4 under the radical plus the bottom minus 3? Non-real calculation.
Okay,
I don't think you can afford.
Yeah.
okay, so let's see. If I plug negative 4 in, negative 4 plus
Well, then you get negative 4.
And the square root of 1.
square root of 1 is 1. I get negative 2 equals negative 4.
did we get wrong?
We didn't do anything wrong.
It's now silly.
It's an extraneous root. So that one isn't a real answer.
So
This
it's
one.
just a negative.
All its life.
So see what I mean? You have to check.
Are we your
So-
first class of algebra 2?
In the day, you mean?
Mhm.
Yes. Well, yes and no. Second period. Third period. I teach it over there, third period. But they're not doing it. They're not this part yet. Okay, so let's say this is the SAT. And they give you this problem on the SAT. And they give you 4 answer choices. I can guarantee you one of the answer choices will have x equals -4 and x equals -1. And if you choose that because you didn't check your answers, you're wrong. Because the answer is only -1. Yeah?
Can they give us half credit?
No. Not on the SAT. So you've got to, and I'm not gonna give you half credit on the test for this chapter, so you have to check for extraneous roots. So, there you go. Okay, so let's do a couple more. Alright. Okay, so now we on sample problem A, we're isolating the radicals. So anything outside of the house has got to be gotten rid of, if you can get rid of it. So in this case we can, so I'm going to get rid of the -3 and the 2. Get rid of the -3 first because that is most loosely attached. A plus is a lot easier to get rid of than a multiplication. So. Okay, so everybody good so far? Now I'm going to get rid of the 2. How am I going to get rid of that 2?
And just divide it all.
Yes, divide by 2.
Will that just cancel that out?
Uh-huh. So now I have square root of x plus 7 equals 6. Now we got to square both sides.
I love math.
Subtract 7. So I get x equals 31. Is that right?
29.
Oh, wait.
I was just saying.
No, 29.
I was about to say, I'm
Oh,
I don't know what just happened in my brain.
I love math.
Okay, x equals 29. Okay, so now real quick, because I do think you can do this in your head.
You can.
Take 29's figure right there. 29 plus 7 is 36. Square root of 36 is 6 times 2. 12 plus 3. So we're good.
Yeah, I did not calculate as fast as they did. I was still
4 plus
thinking
3.
29 plus 7.
Crazy?
Okay. Here's problem B. The radical is already isolated. That's nice. So we can just jump straight to squaring both sides.
So basically just x equals x squared equals x plus 1.
Yes.
But how would you subtract that x? Would you just do x squared minus x equals 20?
Yep. I'm going to move everything because anytime you get to a situation like this where it's a quadratic, everything has to go to one side because you're either going to factor or you're going to use quadratic formula. And either of those require that it's set equal to 0. So I'm going to move everything over. So that makes it x squared minus x minus 20.
Minus 5 plus 4.
Minus 5 plus 4.
Oh, you factored.
You can use quadratic formula if you want to.
Oh no, that takes way too long.
Yeah, I agree.
It's only
Okay, 5 worked.
Yep, 5 works.
4 doesn't. -4 doesn't.
-4 doesn't. Because when you plug -4 right here, you get -4. When you plug -4 right here, now, let me clarify. When you take a square root, how many answers are there really?
2.
2, positive and negative. However, when you're checking for extraneous roots, remember we were talking about functions here, and remember what we did to our square root when we dropped off the bottom.
Yeah.
It's only the
So we
positive,
only
the
do part.
primary root. So -4 doesn't work, because -4 doesn't equal 4. Does that make sense? Everybody
It's
with
still
me?
a real solution though, right?
So like it will never work?
No?
Not in this problem.
It didn't work in the last year.
Right. Yeah, it didn't work. Oh, that's just coincidence.
Oh, okay.
Yeah, I don't know why, but -4 will work in some problem. It just didn't happen to work in any one of these. It's just coincidence that it was the same over the place. radical.
How do you do that again?
Once you get the radical isolated, you have to square both sides.
Or it's minus 3 equals 4.
And now you just solve for x.
That was a simple one.
You don't know if it works yet.
Well, x equals 13. Plus or minus 13, right? There's two, that's two roots.
No, because when we solved it, there's no reason for us to take,
Yep.
right? We didn't take the square root anyway, so. Now just take 13 and plug it back in.
52 minus 3, 49,
Yep.
minus 10, 39.
There's no equal negative.
Wait.
If you don't.
It is. 7 minus 10 is negative 3, negative 3 equals negative 3. So it works. Is everybody okay?
Yes.
All right. You do this. You do not have to do the challenge. We'll do the challenge problem tomorrow together.
Monday.
I mean Monday.
So, do we turn this in when we're done?
Yeah, if you finish before, yeah.